So
This one.
let's try an example of calculating a cross product
Okay.
where we want to calculate the quantity I plus j crossed with the quantity I cross j. Okay. So let's see, what three things does a cross product? Three. What three things does a cross product do?
Right hand rule.
Right hand rule,
Perpendicular to
perpendicular to both the inputs, and
magnitude of
yeah, the magnitude is the area of the parallelogram. Okay, so that should be all I ever need. Although sometimes you want that formula because it's just faster than sorting it out. So on this guy, let's see. What do you start with?
cross the I and J.
Yeah, probably this. Okay, so let me see. That's like, all right, I points in the x direction, right? So where should the j be?
Isn't it?
J should go this way then, right?
Uh,
Okay, so yeah, now I need a right-hand rule, so I know this is going to stick straight up towards me.
yes, okay.
So that's k, right? It's positive k. I'm really kind of looking at this and I'm thinking, all right, there's an x-axis, there's a y-axis, there's a z-axis, and I'm doing this thing cross that thing. So I'm getting something that points along the z. So that guy is going to be k. And I'm still supposed to do I plus j cross that. Okay, so then what?
And then you can distribute the
yeah.
cross product.
Yeah, you can distribute the cross product. Okay, so I'll get I, wait.
I cross K.
Okay, and on the cross product, you have to be careful about the way you distribute, right?
Yeah, then that's in parentheses.
Yeah, so I gotta do that. I cross k
And then
plus
J cross K
j cross k.
in parentheses.
If the k was on the left, it would be j cross I, or sorry, k cross I, k cross I.
Yeah, so if the k was on the left, you'd distribute the other way, right? And the k would still be on the left when you were done. Remember, that actually makes a difference with cross products because there's this orientation thing that comes out of the right-hand rule. All right, so if I do I cross k,
Negative J.
let's see. So let me throw my axis up here for reference. So that'd be I and k. Yep, so that's got to stick out at me, and it's going to be one long because they're,
That's
so the
magnitude.
parallelogram in this case is a square, right?
Yeah.
You guys see that?
Uh-huh.
So that's going to tell me how long that is. And if it's a square that's 1 by 1 because they're both unit vectors, then I'm going to get a unit normal, right? That's that k, or minus j rather. So I got minus j out of that piece plus, what do you get when you do? So that'd be j this way, k that way. Right hand, wait, j then k,
Yeah,
good.
so
Right
just-
hand rules this way, so I get
I.
I. So I got minus j plus I.
can-
Do you stick that together?
No.
Yeah. You could write it component-wise, right? What are the components on that one? Oops, sorry. It said round brackets. 1, -1, and I kind of lied to you a little bit, right?
Yeah.
Because there should be a
Okay.
0. Okay, see that? How do I know this result had to live in 3 dimensions?
Everything else was.
Because everything else was, and because the
It's only in 3 dimensions.
yeah, the cross product doesn't make any sense in 2 dimensions, right? Because there's nothing that's perpendicular to 2 vectors. Does that make sense? All right.